As the story goes, one day Isaac Newton was chilling underneath an apple tree when an apple suddenly fell from the branches, hitting him on the head and knocking him unconscious. When he finally woke up, he had a vision that would revolutionize the idea of time travel. So he hopped up, ran inside, grabbed a pencil and paper, and drew this. Now all he needed was to get a 1985 plutonium-powered DeLorean up to 88 miles an hour. Huh? That wasn't Isaac Newton? Who's Doc Brown? Oh. Journalist James Gleick once wrote, Isaac Newton was born into a world of darkness, obscurity, and magic, veered at least once to the brink of madness, and yet discovered more of the essential core of human knowledge than anyone before or after. He was chief architect of the modern world. He made knowledge a thing of substance, quantitative and exact. He established principles, and they are called his laws. Sir Isaac Newton is known as the father of modern physics. He was an English mathematician, a physicist, and an astronomer, as well as a theologian and an alchemist. He invented integral and differential calculus, proved that white light is a mixture of colors, built the first reflecting telescope, discovered the binomial theorem, introduced polar coordinates, and showed that the force causing objects to fall is the same force that drives planetary motion and causes tides. But Newton is perhaps most well known for discovering the 3 laws of motion. The first law is most commonly referred to as the law of inertia. It states that an object which is either in a state of motion or at rest will remain in that state until acted upon by an outside force. For example, after placing a golf ball on the tee, the ball will just sit there at rest until an outside force comes along and moves it. This could be the force of the wind blowing the ball off the tee or a golfer's club hitting it down the fairway. The second law states that when a force acts upon an object, the rate at which the object's momentum will change is directly proportional to the force applied to it and inversely proportional to the object's mass. This basically means that the heavier an object is, the more force that is required to move it. Newton even provided us with this equation to show the exact relationship between force, mass, and acceleration. Using these standard units of measurement, we'll visualize the second law by calculating the acceleration of the dog sled shown here. In this example, the sled has a mass of 50 kilograms, and a single dog can pull with the force of 100 newtons. The first thing we'll need to do is modify the force equation so that we get acceleration equals force divided by mass. From here we just plug in the numbers, and there you have it. A single dog pulling a 50 kilogram sled with a force of 100 newtons will accelerate the sled at 2 meters per second squared. Now if we increase the mass of the sled to 100 kilograms and do the math again, we see that the dog will only be able to accelerate the sled at 1 meters per second squared. The third law is often simplified by saying every action has an equal but opposite reaction. This law states that whenever one body exerts a force on a second body, the second body exerts a force on the first body that is equal in magnitude but opposite in direction. We as people experience this every day. As gravity pulls each of us down towards the center of the Earth's surface pushes back on us with an equal force, but in the opposite direction. The third law is also the reason we understand rocket propulsion. In a rocket, the fuel is ignited in a combustion chamber, causing the heated exhaust to be accelerated out the back. The force of the exhaust leaving the rocket is what propels it into the sky, in the same way that releasing air from a balloon sends the balloon flipping through the air
like Eddie Gordo from Tekken when someone doesn't know combos and it's just pushing the buttons randomly.
So there you have it. The laws of motion are all you need to describe how everyday objects move, from soccer balls to space stations. Newton gave us the means to plan a journey to the moon. It just took us 300 years to invent the rockets we needed to get there. Holy for the world, which is why anyone can identify that sweet after the rain smell. Another smell commonly associated with rain comes from the volatile oils that